In this short video, I'm going to explain to you a little bit about what engineering practice actually is. And this, we're going to develop a diagram here. This diagram has been adapted from a book chapter written by James Trevelyan from a book. The chapter's called Towards a Theoretical Framework of Engineering Practice, and the book's called Engineering Practice in a Global Context. So a professional engineer has many different roles, and of course to become a professional engineer one must learn a body of knowledge which includes science, mathematics, analysis, design, theories, skills and so on, and these skills get updated throughout the professional engineer's career with continuing professional development. And of course, how does the engineer learn this? Well, they go to a university, and the university provides learning opportunities, and they graduate that professional engineer, and in doing that they verify that the engineer actually has the requisite body of knowledge and that they can also apply this in certain situations. And that system's regulated in Australia and many other parts of the world because of professional associations such as Engineers Australia, and the Engineers Australia accredits the university, and of course the professional engineer belongs to the professional association and is chartered by that professional organisation. That professional association is then affiliated to international professional associations, and that of course enables mobility. So engineers can move to any country covered by international agreements, and their engineering qualifications are automatically recognised in those signature countries. Professional association also creates a code of ethics and nurtures that code of ethics, and the professional engineer is then bound by that code of ethics. And we'll come back to the code of ethics shortly, but the professional engineer also belongs to an enterprise. Now the enterprise could be an engineering organisation, a large one, or it could be a small one, or it could be a one-man show. The enterprise could be just a company that is run and operated just by that single engineer. But regardless of the size of the organisation, the style of organisation, could also be a non-engineering organisation, could be a bank or an insurance company or whatever. But generally engineers are very critical to the success of the enterprises to which they belong. So they do high value work. And of course clients come along and they have problems that they need solved or things that need to be done, and they engage the enterprise, or the enterprise may bid on work. And then of course in doing so the client will consider the reputation and standing of that enterprise and of course of the professional engineer, and then the enterprise isn't going to employ the professional engineer unless they have a good reputation and standing. Now we'll come back to this later on, but the professional engineer builds reputation and standing by delivering value to stakeholders, by consistently delivering value to stakeholders. So that's very important throughout a professional's career. Now, engineers are all about solving problems, so a client comes along and they describe a real-world problem, and then the engineer works with the client to specify exactly what that problem is. And that is in fact quite a difficult thing to do in the real world, because problems these days are becoming more complex, and so it's very important to determine exactly what the problem is. And then the engineer goes away and determines candidate solutions to that real world problem. They may come up with more than one, and in doing so they're going to do some research and they're going to be drawing on perhaps the work of others. But often what we do in engineering, and this is what we're taught a lot at university, is we abstract and model from that real world problem, and we specify a more simplified problem, and we solve that using standard methods or techniques that we're taught at university, and we come up with an abstract solution, and we then have to interpret that solution back into the real world, and that may yield other possible solutions that we can apply to this real world problem. And of course, in doing so, the professional engineer gains experience, and over time they may work with other professionals and other engineers. So they may work with lawyers, with bankers, with architects and other professional engineers. And those other professionals, of course, draw on specialist bodies of knowledge that the professional engineer may not necessarily fully understand or even be aware of. But it's very important that that professional engineer listens to those other professionals and is able to work with them and use them to solve the problem for the client. So of course, when they're determining their candidate solutions, they're drawing on their own body of knowledge, the bodies of knowledge from the other professionals that they deal with, and of course from their previous experience. So once you've got possible solutions, you then have to work out which one you're going to choose, and there may be a very large number of possibilities, and here the role of the engineer is really to optimize within given constraints, and it's very important at this point that they add value for all stakeholders involved, not just the client but all stakeholders involved in this endeavour. So there they need to use their creativity and innovation, which of course they also need to apply back the previous step where they're determining the candidate solutions. And of course there are many constraints that could come in. And let's have a look at some of these constraints. The first group we could call scientific constraints, and these are limited by the fundamentals of science, things like gravity, material science, electrical conductivity, mechanics, motion, computation, geology, biology, etc. So there's a limit to what the engineer can do based on these fundamental things. So they need to take that into account when they're optimizing within their given constraints. You know, it's not possible to design something that breaks the laws of physics, for example, so the engineer obviously needs to be aware of that. Now, associated with that is a whole lot of specialist bodies of knowledge, and the engineer may need to know about some of those and delve into some of those, or they may draw on the expertise of others. But that's not the only set of constraints that come into this. The next lot are what we call human constraints, and there are things like learning capacity, memory, limits of what people are able to communicate, skills and capabilities of individuals that have to go on and work on this project, negotiation, coordination, sensory, motor, and so on. So these are all human factors, and there are specialist bodies of knowledge associated with all of these, and some examples of those are things such as education, psychology, linguistics. Now the engineer may not need to understand those, but may need to draw on the expertise of others, or perhaps they may actually go off and learn some of these other related areas. Some further constraints are things like logistics, and so the first couple of these obviously come into every problem that needs to be solved: money, time, manpower, tools, material availability, information systems to support the project going ahead, quality, risk, a big one these days, and things like maintainability and so on. So there's a whole lot of logistical constraints that always come into this as well, And specialist bodies of knowledge feeding into this are things like organisation science, economics and finance, project management, and so on. Now, some of these, of course, you learn about in the core program in your engineering degree, but some of these you only learn about in a very simple way, and you may need to learn much more about these as you progress through your career. And of course, typically engineers may go off and do an MBA or a Master of Engineering Management in order to learn more about some of these related areas. And the last lot of constraints here would come under social constraints, and these are things like teamwork, politics, and as you go through life you'll realise that politics actually comes into every single thing that happens in the world. There are legal and regulatory constraints, cultural issues, public safety, environmental, ethical, and so on. And specialist bodies of knowledge feeding into that are things like sociology, ethnography, anthropology, ethics, philosophy, and political science. So you can see there's a huge number of possible things that may come in to this very important step of the process, which is to go from possible solutions to the final chosen solution. And that takes a great deal of skill and craftsmanship on the part of the engineer to navigate through all these constraints and optimize to maximize value for the stakeholder, all the stakeholders in the project. So of course, once you do come up with a chosen solution, and often you may need to go back to the client and negotiate with the client through that process, you'll choose a particular solution, and then you'll formulate a plan and assemble a team to bring together a project to work on this solution to implement it. And there you need to arrange resources, money, and tools, materials, and so on to actually enable the project to move ahead. Now, because during the life of the project you have to manage the project, so there's all sorts of project management skills. There needs to be documentation maintained. Sometimes that needs to be transparent with the client, and then eventually you'll get to the point where you finish the project, or at least finish the project to the point where you commission, and you end up with a final product or process or information or system. And of course you may need to go back and verify that you have actually met the needs of the client. Has the final system or product or process or information actually met the design brief? And ultimately the end user needs to be satisfied and need to actually benefit. There needs to be some positive gain on the point of view of the client, and the end user may or may not be the client. So that's just another little thing you've got to take into consideration. Now, of course, during the life of the system or whatever it is that's been implemented, you need to maintain and operate that particular thing, and there may be further projects to modify and or upgrade, and you may need to go back and run another project, and that's of course where your documentation is really important. And finally, when the thing is no longer required, reaches end of life, we decommission, and we need to reuse, recycle, or dispose of. And of course we need to take into account the local and the global community before we do that. And in fact that should actually be part of the design process back in the optimization. When we go from possible solutions to a chosen solution, we should think about what actually happens at the end of life. So you can see there's a complex process here. Many things come into it, and we've talked about the local and the global community. Well, the client and of course the engineer belong to the local community, and the local community is of course a subset of the global community. And so the engineer has a responsibility to these communities and to public safety and social well-being, and these also need to come into the design process. And there are other stakeholders who need to be identified who also belong to the local community, and it's important that the engineer can identify those and also consult with other stakeholders. So the global community then, of course, needs to be considered then when you're working on your creativity and innovation and working on your design processes. Now, during all of this, of course, you're gaining experience, and what you're doing is you're drawing on the experience of going around this process possibly many times throughout one's career and reflecting on what works well and what doesn't, and that is going to build up your experiential knowledge and allow you to perform these functions more effectively. And that's really a key function of being a professional, is you need to be able to evaluate what you do and improve on it. So there's a feedback cycle involved in that whole process. And of course, your code of ethics enhances your reputation and standing, not just with the client but with the community as well. So there are many aspects to this, and of course, another important ability of an engineer is to undertake peer review with other professional engineers and possibly other professionals, and that also helps them to improve. And throughout this whole process, the engineer, of course, has to manage themselves. Let's have a look now at the FEIT graduate attributes and see how the graduate attributes are really enablers of many aspects of this area of engineering practice. So the first one of these is A1, which is needs, context and systems. Engineering and IT take place within the larger context of society and the environment, which encompasses social, economic and sustainability needs. So that's an enabling skill where the professional engineer has to consult with other stakeholders and the local and global community in order to meet their needs as well and deliver value. The next two are problem solving and design, and abstraction and modelling. So these of course come in to these two very key areas of the diagram where the engineer is working to identify candidate solutions and optimize within the given constraints to choose a particular solution for that particular client at that particular point in time. So very important set of skills there. The next one is C, which is abstraction and modelling. So that's a very important part of that upper loop there that we talked about earlier. The next one is self-management, D1. Manage their own time and processes effectively by prioritising competing demands to achieve personal and organisational goals. And the second one of these is absolutely critical, D2. Reflect on personal and professional experiences to engage in independent development beyond formal education for lifelong learning. Critical. And the next one, E1, is communicate effectively. Now this obviously goes to many areas of this diagram. So you've got it in up there near the client, but obviously down around working with other professionals, and of course teamwork comes into it there, E2 as well. And then we've got E3, project management methodologies, be able to identify and apply relevant ones of those. And F. F1, be able to conduct critical self-review and performance evaluation against appropriate criteria as a means of tracking personal development needs and achievements. F2, appreciate ethical implications of professional practice. F3, understand cross-cultural issues, so the cultural aspects of the social constraints come into that, but also in terms of working in projects and in teams and so on. And the last one of the graduate attributes, F4, be aware of global perspectives, needs, rules, regulations and specifications. So that's where we would map our graduate attributes, and of course this is just a rough mapping. There could be many other places in that diagram where these things come into it. Let's move on now and look at the Engineers Australia Stage 2 competencies and where they might map into this diagram. And the first one's a no-brainer, that's deal with ethical issues, element number 1. So that's up there next to our F2 for FEIT graduate attributes. And next one, E2, practice competently, regularly assess your own competence, maintain a concise description of your areas of competence, carry out engineering work only within the boundaries of your known areas of competence, and maintain records of continuing professional development activities. Pretty important one there. Number 3, E3, responsibility for engineering activities, which involves seeking peer reviews, but a whole bunch of other things as well. E4, develop safe and sustainable solutions, similar to our F4, and engaging the community and stakeholders comes up there under next to A1. And the next one is E6, which is to identify, assess and manage risks. And so that one actually comes out in a number of places over here in our logistical constraints, E6, but also considering our reputation and standing is another area there. And E7, legal and regulatory requirements. E8, communication. Well, that comes up in so many different areas, and so we've got that there under real world problems, but also down here with other professionals, and also with working with the client. So that's a pretty crucial one there. The next one is E9, performance. Means that you can work within your enterprise and with clients effectively. And E10, taking action on projects and other areas as well. E11, judgment, pretty important one there. That comes back to our largely to our optimization processes, but other areas as well. E12, advanced engineering knowledge and local engineering knowledge. E13 comes under our social constraints and various other areas. Problem analysis, working with the client to determine the actual problem, making sure we deliver value to all stakeholders. E15, creativity and innovation. And E16, evaluation, making sure that we actually verify that what we do is meeting the needs of our original design brief and that of the stakeholders. So that's our model of engineering practice, and you can see it's fairly complicated. There's a lot of things going on. Of course, the real world is much more complex than this. This is really just a simplified model, but it gives us a bit of an idea of the breadth of what constitutes engineering practice, the complexity of it, the interrelationship between so many different areas of engineering practice. And we can see from this that engineering is a very social activity. It's absolutely integral to what's going on in the local and the global community, and that it's also a very human activity. You can see so much of this diagram involves humans and human activity and the limits of what humans are actually able to do. So the professional engineer, needs to be aware of all of these different areas and to creatively and innovatively make use of the best of what's available to her or him to ultimately deliver value for all of the stakeholders in an effective and appropriate manner.